Okay, good morning class. So today we're looking at the Susie grade 10 paper. This was last year's grade 10 paper. Okay, final exam. It was 2 hours, 125 marks. If you had looked at the group, I posted the scope for the final exam as well. Okay, this exam was set up according to that scope as well. Okay. So let's go. So here we are told in number 1. Okay, you guys have done this paper at this point, and you have marked it from the memo at the back. Okay. So if there's any questions that still doesn't make sense to you, you just stop me and I'll try and explain what the misunderstanding is. Okay. So it says write down whether each of the following statements is true or false, and justify your answer. Use numerical counterexamples where necessary. The product of two irrational numbers is always, product of two irrational numbers are always irrational. Why do you say that is true or false? False. Why? Because if I look at the square root of 5 times the square root of 5 is 5. Okay. Also, if you look at the square root of 2 times the square root of 8, that's going to be the square root of 16, which is 4. So, the product of two irrational numbers are always irrational, is false, and there's your counter argument. Okay? Yes, Michael? Any of those, yeah. Yes?
Are they always irrational?
No. So there's irrational, but if you look at the square root of 2 times the square root of 3, that is the square root of 6. So that is irrational, and is equal to irrational. So they wanted to know, is this always the case? No. And the answer is, it's not the case there, so it's not always the case. Does it make sense?
Yes, sir.
Let's look at 1.2. The square root of a plus b equals the square root of a plus the square root of b. Let's check. What's the square root of, another one is 16? And 9. Yeah. The square root of 16 plus 9. That is going to give you? 25. The square root of 25 is 5. So the square root of 16 plus the square root of 9 is equal to 4 plus 3. Is 7 the same as 5? No. So this is false. And there's your counter example. Okay? Does it make sense, people? Alright. Let's look at the next one. For which value or values of x is the square root of x a real number? People, under the square root number, the number must always be positive. So for which value or values for x? When we find the positive numbers, where it is greater than 0. Not so. All of those numbers are positive. What's the square root of 0? 0, so I can include that as well. So in other words, x must be greater than or equal to 0. Okay. Yes. This is not a true or false question. The true or false question was for question 1.1. Okay. People, let's look at number 2. Simplify the following completely. So we do start here. Start by multiplying this bracket out. Not so. So that's going to give us 3a squared minus open brackets 3a squared plus, that's going to give you 6ab minus 4ab minus 8b. So I can do one of two things. I either multiply out the bracket, or I can add like terms inside the bracket. Not so. So you're going to give you 3a squared minus 3a squared minus 6ab plus 4ab plus 8b. So that cancels, not so. So negative 6ab plus 4ab, negative 2ab plus 8b squared. Okay. Let me know when I make a mistake, okay? Let's look at the next one. People, with this negative exponent, what's gonna happen here? The question paper and memo can be found in the description box below, okay? Should we go to the numerator? Let's just make this bigger. Alright, because of that negative exponent, that's going to move up. So that's simply going to give us a quarter x squared minus a third squared all over 1. And anything over 1 is that number, not so. Now what? It becomes a binomial square. One of two things I can do. Either multiply, write it out twice, or apply the binomial square rule. So we take the first term and we square it. What is a quarter x squared all squared? 1 over 16 x squared, x4. It's going to be the first term times the second term times 2. So it's going to be a quarter x squared times negative a third times 2. 2 goes into 2 once, 2 goes into quarter twice. So what do I have? X squared over 6. Or 1 over 6 x squared. You all agree with that? Huh? 1 over 6 x squared. And of course the last, this must be minus. And the last term squared will always be positive, so a third all squared will be 1 over 9. Okay, is there any confusion there? Sorry? No confusion. Alright. Let's plug my charger in. 2.3. People, what needs to be done here? We'll factorize first, not so. So if you're looking at the numerator, what type of factorization there? Common factor of b. So I'm left with a minus b. What type of factorization here? So it's a plus b, a minus b. This we change to? Tumble and tie. What type of factorization here? Common factor of a. I'm left with over okay. So I can cancel here. A plus b. And that cancels. So what are we left with? A. So it's a over 1, which is? Do I need to write it a over 1 there? Also, if that a was in the denominator, then I would have written it as 1 over a. Okay, and you couldn't just have left a on its own. Yes, Michael? Your hands up, you don't even know your hands up. Okay, any questions with regards to the sum here? No? I'm moving too fast. No. Okay, let's look at the next one. I'll try and move a bit faster. 2.4. Simplify. So what do I do first? I find a common denominator. LCD or LCM. So between 116 and 4, what's your LCD here? 16. So you multiply this by 16 times this by 1 and this by 4. Okay. So it's going to be 16 times 3x minus 1 into 4x plus 4 minus. Now 3 times 4 is 12x minus 1. Can I drop the denominator here? No. 16 times 3 I think is 48. 48 yes. So it's 48x minus, so we multiply this out here. People, this is a common made error here. when learners don't write this first. Okay, and then they multiply one time out here at the same time. No? But then they forget that this negative must also be multiplied. That's why you'll always see me writing it out like this first, so that we don't make that mistake. Okay, so it's going to be negative 4x minus 4 minus 12x plus 12. Now gives us, can I drop the denominator? No. When can we drop the denominator? It's an equation with the equal sign. So it's going to be 48 minus 4 is 44 minus 12, 32. 32x minus 4 plus 12 is, what do we notice? We have a common factor of 8 here, not so? So if we take out 8 as a common factor, 8 as a common factor, what are we left with? 4x plus over 16. So 8 goes into 8 once, 8 goes into 16 twice. So the answer is 4x plus 1 over. Any confusion there? Sorry?
So is that the answer?
What do you think the answer should be?
I got 2x plus 1.
It's the same? You're saying it's 2x plus half. What you did was you put each one over its own. So it's going to be 4x over 2 plus 1 over 2, which is 2x plus half. Yes, absolutely. But did I need to do that? No. Okay. I'm going to get extra marks. Right. Anything else? Who's writing Billy? Oh, it's you. Okay, nice, nice. Thank you for yesterday. Yeah? She reminded me. Okay. Reminded me that I didn't post the paper today. Right, 3 point. So she's taking a math serious, no? And you're actually upset that she reminded me. Eh? You're not upset? But you didn't do the homework. You did? Nice, nice. I like it. Right, so what do we do here? What can happen here? 9 goes into 9 once, 9 goes into 27? 3 times. Okay. So it's going to be a third. Where's the more x's? Cancel. Okay, it's the same. Where's the more y's? On top. So we bring that up. So it's going to be y 5 plus 5. So it's simply y10 over 3. Okay. Or it can be written as a third y10 or 1 over 3 y10. It's all the same thing. Okay. Verstaan julle? Okay. How do you say you understand, Kosa? Siakul. Huh? Sikonda. Sikonda. Okay, I'll try and remember. Alright. People, 15 to exponent n plus 5 to the n over 5 to the n plus 1. Right. So can we cancel 5 into 5 once, 5 into, and then, no, because that is the exponent. But because there is a plus or minus between it, I'm going to break up and factorize where we can. Not so. Break up and factorize. So the 15 can be written as 3 times 5. Raised to the n plus 5 to the n over. This can be broken up into 5 to the n times 5 to the. So you multiply the exponent, so it's 3 to the n times 5 to the n plus 5 to the n over 5 to the n times 5 to the 1. Can I now cancel the 5 to the n? No. Because of the plus between. Okay? So what is common? 5 to the n. What are we left with? 3 to the n plus 1 over 5 to the n times 5 to the 1. This goes on the side. Stop it please. No? Now what? Cancel. As you can see, it's unlike term, so it's going to be 3 to the n plus 1 all over. Okay. Is there any confusion? Right. Number 6. Sorry, 6 marks. Question 3.1.3. We got 3 x cubed raised to exponent n plus 1 times in brackets x y squared raised to exponent negative 2n all over x y to the exponent n times y to the exponent negative 5 to the 5n. What needs to be done first? Multiply the exponents. So in other words, 3 times n, 3 times 1. So it's x to the 3n plus 3 times x is a 1 here, not so. 1 times negative 2n is negative 2n. Y 2 times negative 2n is negative 4. That's all over. X y to the n times y to the negative 5. Okay. Now what? When we are multiplying and bases are the same, we add exponents. When we divide, we subtract. So it's x. So only the basis of x's exponents can be brought together. Can you see that? So we got x to the 3n plus 3 plus minus 2n minus 1b. Right, you all agree with that? Times y. So only the exponents with a y can be brought together. You all agree with that? So in other words, it's going to be negative 4n minus n plus 5. Okay. So what is 3n minus 2n? 3 minus 1 times 1. What is minus 4n minus n? Negative 5n plus 5n cancel. So it's y to the people. Anything to the power 0 is 1. So it's going to be x n plus 2. Many wrote y. The exam of last year. Okay? But remember, if there's no number there, when there's a 1. That is why we must put y to the 0. And as we know, anything to the power 0 is 1. Okay, yes, Michael? Why is it? Plus 5. Because we're bringing that 5 in from the denominator to the numerator. Whenever you bring a plus up, it becomes a minus. If you bring a minus up, it becomes a plus. Alright, you guys understand? Any other questions? No? 3.2, solve for x. Show all calculations. So what needs to be done here? They get 250 over the equal sign. It becomes 2 times 5 to the x plus 1 is equal to 250. Now what do we do? Yes, Michael?
What is the previous question in our papers?
Hi.
Now I know.
All this type of questions will come in. We'll just change the number. Can I change some of the numbers? Okay, I'm not setting this exam, I'm setting you paper 2. Okay. So I divide by 2 both sides. And you ask so nicely, imagine I could have done it for you. This is a pity, man. Alright, so 250 divided by 2? 125. Now what do we do? 125 can be written as what? So we say 125 equal shift and this button. Okay? No factorized button on this calculator.
It's the dot dot dot.
Yeah, but it's not dot dot dot, yeah, man. Let's get the other calculator. Delete that one. Yep. So say 125 equal shift factorize. That can be written as 5 cubed. People, this is an exponential equation. So we want the bases to be the same for the exponents to be equal. You can equate the exponents. So therefore, x plus 1 is equal to 3. X is then equal to? Yes. Yes?
Is it fine if
Shh.
is it fine if you took your 250 and put it outside and then you see 3 times 5 to the power 3? Do you still get the same? Because I got the same answer.
Okay, so you're saying you went straight, whoops, and you say 250 equals shift factorize. So you said it's 2 times 5 to the x plus 1 is equal to 2 times 5 to the cube, and then you equate those exponents 100%. Okay. Anything else? Yes? Looks like you're going to pass. Or you're going to do well as well, not only pass, no? People, let's look at 4.1. Question says, solve for x. In 4.1.1, I can do this one of 2 ways. If I introduce a square root, what must I not forget? Plus minus. There you go. Square root both sides, plus minus. So x is equal to plus minus 2. Otherwise, if you had x squared is equal to 4, we bring that over the equal sign, becomes x squared minus 4 is equal to 0. Now what? Friends of 2 squares, yes. Our favorite. Dots. So x plus 2 is equal to 0, or x minus 2 is equal to 0. So x equal to minus 2 or x equal to either or, you get full marks. Okay.
So if you don't write plus or minus, then you use marks.
What do you think? Yes! Now you're trying to talk to me a little. Huh? Of course you must write the plus and minus. What kind of girl are you? Right, 4.1.2 people, what type of sum is this? Trinomial. Trinomial quadratic equation. So, product line. What goes on the line? 4, 1 and 4. And 2 and 2. 4, 3, 1 and 3. Do we add or subtract the products? Subtract them. So it's 4 minus 3 is 1. That's 6 minus 2? 4. And that's what I want. Not so? So in the bracket goes a 2 and a 1. 2x and a 1. A 2 and a 3. What about our signs? Plus and minus. Different signs. The one must, the bigger one must be negative. So that's going to give you 6 and that's 2. So 6 is larger, not so? So 6 must be negative. Okay. So in other words, 2x plus 1 is equal to 0. 2x is equal to negative 1. So x is equal to negative 1 over 2. Or 2x minus 3 is equal to 0. 2x is equal to 3. Divide by 2. 0. Yes, Lisa Kanya. You got the same answer?
No, sir. I got 4x.
Okay, so what did you have in the bracket?
I said 4x minus 3.
4x minus 3
And 4x plus 3.
equals 0?
Yes, sir.
Okay, now just hang on. So you should say that is the same as that there. So 4 times 4? 16x squared. which is not that. And that's going to give us plus 12x minus 12x minus 9 is equal to 0. It cancels, give you 16x squared minus 9. You see this? And that is not the same. Did you use the product line? Now you see, if you catch on your own Mickey Mouse, you won't get the right answer. You understand? The reason why I teach you this stuff, Lisa, kind of my girl. Okay. So brush up on this here. Okay. Next. 7 marks. Hendrix, wouldn't you like this one also in your exam? Just like this. But if you will understand it, at the end of this question. Right, so where do we start? Factorize the denominator, not so? That can factorize into x plus 1, x minus 1. Minus x squared over x plus 1 equals 3x over x minus 1. People, what is my LCM here? X plus 1, x minus 1. That's coming from the first bracket. But if you look at the second one, that's already accounted for there. And x minus 1 is already accounted for. We get the restriction. What's my restriction here? X cannot be equal to 1 or minus 1. Not so?
Yes, sir.
Otherwise the sum will be undefined. So you ask yourselves, okay, what must this be multiplied by to get the LCM? By 1. Right. That we also multiply by 1. So it's going to be 2x into 1 minus. What must this be multiplied by to get the LCM?
X minus 1.
X minus 1. Okay? So it's going to be x squared into
X minus 1.
equal x plus 1. So it's going to be 3x into.
X plus 1.
Do I write it over the denominator? No, I can drop it because that's an equation. You understand?
Yes, sir.
So what do I do now? Simplify. Into the bracket, so it's going to be 2x minus x cubed plus x squared equals 3x squared
Plus
That's
3x.
As you can see, I have all x's involved. Not so, it's not linear. It's actually a cubic equation. So if it's anything but linear, then I take everything to one side and have 0 on the other side. I bring everything to the right hand side, so 0 is equal to 3x squared plus 3x minus 2x plus x cubed minus x squared. So that's simply going to give us x cubed. That's like this. So it's going to be plus 2x squared plus x. So what do I notice now?
It's a triangle.
A trinomial name. But prior to taking out the factors for the trinomial, what else do you notice? Common factor, common x, yes. What are we left with?
X squared.
X squared plus 2x plus.
1.
So now this is a trinomial, it's a perfect square trinomial. It's x plus 1 squared. Or if you didn't know that, you can take it to the product line. The bottom 1 and 1, 1 and 1. We add or subtract? Of course we add it. So instead of writing it as x plus 1 squared, you would have written it as x plus 1 times x plus 1. Okay. So we set each factor equal to 0, so x is equal to 0 or x plus 1 squared is equal to 0, the square root thereof, and then you take this over. So x is equal to negative 1. Now coming back to the restriction, what did we say here? X cannot be equal to negative 1 or 1. So we must omit that solution. Okay. By putting a line through it, you are acknowledging that x can't be that value. Yes, Michael?
Do you get a mark?
Yeah, if you don't pull this line through here, you will have lost 1 mark. Okay. But you don't want all your marks, must. No? You do want to. Then you must pull a line. Okay. You guys understand? Amber, you're looking like you're enjoying yourself there, not doing no work. You am. Oh, you're marking. Oh no, I'm talking to this one. Yes, you know. Oh, you swap seats today. For once I get your name right and then you're not sitting on that. Right. People, here we are told that. Well, that's just a bit too big, no? 4.2. Make D the subject of the formula. Right, so what do I do first? Huh? Divide by D. Bring the 4D over. Get the D's on one side and everything else on the other. So dy minus 4D equals? Now what do we do? Common factor. Yes. We left with? Y minus 4 equal? How do I get D on its own? I can't believe it's so easy. So D is x over? Okay. How many marks? 3. 3 marks. Right. Anything else? Any other questions? No? 4.3. Given 2x minus 3x, 2 minus 3x has to be greater or equal to 3, but less than 5. Solve for x in the given inequality. So what do I do first? Minus 2 both sides. The 2 in one solution. So it's 2 minus 3x must be greater than or equal to 3 minus 2. Sorry, I must get rid of that 2 then. But less than 5 minus 2. So that's going to give you 1 and 3. So what do I do now? Divide by negative 3. What's going to happen to the inequality when you divide by negative? Swap around. So it's going to be negative a third x and negative. You will agree with that? So that means you say x must be greater than negative 1 but less than or equal to negative a third. You can rewrite it if you want. So normally we write the smallest number on the left hand side. But you wouldn't have been penalized if you left it like. The next question in 4.3.2 we are told hence represent your solution in question 4.3.1 on a number line. So what is your critical values on your number line? Negative 1 and negative 1 over 3. I don't need any other numbers. Of course it's in your x bar because of that being x. Does negative 1 get a closed or open circle? Open circle. The negative 3, a third? Closed solid circle. So what does it say? X must be greater than negative 1. So I'm going in the positive direction. And x must be less than or equal to. So there we go. Okay. Yes.
Can you do it the other way around since negative a third is smaller than negative 1?
It's not. How is negative a third smaller than negative 1? We look at your number line. 0, 1, minus 1, minus 2. Where would negative a third lie on this number line? Here, miss. There's negative a third here. So which one is smaller? Negative 1. Did you see that? But if you go the other way, and 1 is here, then the third is here. Then 1 is larger. You see, but in the negative side, the bigger the number is, and if you put a negative in front, the smaller it is in reality. Okay. Any other confusion? Okay. Let's carry on with our lives. Why are you wearing a crown today? Oh, no, where's your sisters? I thought you were wearing a crown because you caught on nonsense in Miss Business classes. Huh? And I know she's the queen and what. Queen of the lenses. Right. Consider the following pattern. You got 5 in 5.1.1. Write down the next two terms in the sequence. How do I move from one term to the next? Minus 3, minus 3, minus 3. So here was minus 4. Oh, 3, okay. Don't get upset, I'm just testing you guys. Okay. So if I minus 3 by negative 7, it's going to be negative 10 minus 3, negative 13. Okay. So now write it here. Right. Next question. It says determine a formula Tn, the general term of the sequence. People, since this is an arithmetic progression or an arithmetic sequence, it follows a formula Tn is equal to a plus n minus 1. Otherwise, some of you use this Tn is equal to Pn plus Q. Let's do both ways. This here is the number that we're adding or subtracting all the time. In this case, it's going to be negative. Okay. So that's going to be negative 3n. So if n is 1, then this is negative 3. What must be added to negative 3 to get 2? 5. And we test it on the second term. Okay, so this is term 2, not so. So what is negative 3 times 2? Negative 6 plus 5? Negative 1. So that's the general. Otherwise, use this formula. A is your first term, 2 plus n minus 1 times your common difference, which is negative 3. Get rid of the brackets. So it's 2 minus 3n plus 3. So it's going to be negative 3n plus. Although it's one extra step, two extra steps. I like this method because I don't like thinking. No? You just want to work through it. I don't want to guess. No? Right. But you guys are different type of girls. So you like the guessing type of some, then you just follow that one, otherwise the other is suffice. Okay. Right. 3 point. Where did I get this now from? It's a grade 11 son. Didn't I cut this? Alright, anyway. People that are told in this question, settle down please. We told the matches have been used to create each of the figures illustrated below. So how many matches are used here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that correct?
Yes, sir.
12 matches. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. Huh? 18. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19. Huh? 18. Who else got 18? Who got 19? I'm feeling better about myself. Right? So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 6, 26. What did you get here, Michael? Okay, I think your counting skills needs to be upgraded then. Right, let's see what's going on here. Now with that in mind, the question says number of squares. How many squares are here? 1, 2, 3. So it's 1, 2, 3. Now figure 4 is not drawn. Yes, Michael. So if this follows the pattern, how many squares are going to be here? 4. Here? 10. As you can see, the same as the figure number. If there's n squares. Okay. Number of triangles. So I look at triangles here is 4. Here is 1. So your triangles is 4. Here's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So what's happening here? I'm adding 2 all the time. Not so. But if I work out the general term here, then if I got 4, 6, 8. So I've worked the formula Tn is equal to A plus n minus 1d. What's your A value? 2 plus n minus 1 times 2. So it's going to give you? So it's 4, not 2. No? So it's going to give you 2n. 4 minus 2 is plus 2. So that's the general formula for the number of squares. Triangles. You all understand that? So now coming back to this here, the table. And I can test it. This is term 2. 2 times 2 is 4 plus 2 is 6, which makes this right. Can you see that, people? 6, 8. This one would be 10, it was 2 more. Now here, n is now 10. 10 times 2 is? Plus 2 is? 22. And of course for n? 2n plus 2. Number of matches. Again, we're going to work out the formula. So for the number of matches, it was 12, 19, 26. So how do I move from one term to the next? You're adding 7. Not 5. 7. You all agree with that? The formula is Tn is equal to 7n minus is plus 5. No? Is that correct? Term 2 is 14, it's 19, yes. Okay. So how many matches are there in figure 2? 19. Then 26. Now in match in 4, I'm just adding 7. It's going to be 33. In the 10th figure, it's simply going to be T10 is equal to 7 times 10, which is 35, which is 75. And then what is for the nth pattern? 7n plus. Okay, any confusion here? Alright. People in 5.3 we are told if 3 to the x minus 1, 2x plus 3 and 2x minus 1 are the first 3 terms of an arithmetic sequence. So what is exclusive to arithmetic sequence? Exclusive. What do we only find in an arithmetic sequence? A common difference. What do we only find in a geometric sequence? Common ratio. Okay. So here, if you got 3x minus 1, we got 2x plus 3, and you got 2x minus 1. These are the first 3 terms of a arithmetic sequence. Okay. So how do we move from one term to the next? We basically say 2x plus 3 minus 3x minus 1. So that is simply minus x plus 4. Okay? What is the difference here? 2x minus 1 minus 2x plus 3. So it's going to be 2x minus 1 minus 2x plus minus 3. It's going to give you negative 4. You all agree with that? So by common difference, yes? Okay, if you got this arithmetic progression here, you all agree that's arithmetic? No? So what do you notice here? 19 minus 12 is? 7. 26 minus 19 is? 7. And it's equal because it's a common difference. It's equal because it's arithmetic. Can you see that? So if I write that in general terms, your common difference will always be term 3 minus term 2, which is equal to T2 minus T1. You can make a note of that. When we did number patterns, the topic, we spoke about that already. Okay. So with that in mind, we're now going to say that your common difference is actually negative 4. Can you see that? So, well, in order to solve for x, I'm going to say that has to be equal. Can you see that, people? It has to be equal. So now, we have negative x plus 4 is equal to negative 4. You get over the equal sign, so negative x equal to negative 8. So x is equal to 8. And people, the nice thing about these sums, you can test it. We're saying x is equal to 8, not so. What's 8 times 3? 24 minus 1? 23. 8 times 2? 16. 16 plus 3? 19. 2 times 8? Minus 1? Huh? 16 minus 1? 15. Oh, 15. How do we move from one term to the next? Minus 4. Minus 4. Which makes it, of course, an arithmetic progression. You guys understand? Yes?
So you basically just substitute this x into the
X. This is just to check here. But did I need to do that? No. So the question asks you to calculate the numerical value or the number value of x. Okay. The question paper memo can be found in the description box below. In our next lesson, we will conclude this paper. People, enjoy the rest of your day. Good morning, class.